4% of all public GitHub commits are now authored by Claude Code. That number, according to the tool's own creator, will hit 20% by the end of this year. Boris Cherny, the engineer who built Claude Code at Anthropic, just sat down with Gergely Orosz of the Pragmatic engineer and laid out exactly how the tool works under the hood. Parallel agents, deterministic review loops, and a prediction that the traditional software engineering title is about to disappear. And then days later, Fields medalist Terence Tao published a video showing himself using Claude Code to formalize a mathematical proof in Lean. Two massive signals in the same week about where agentic coding is headed. Let's get into it. Gergely Orosz, who runs the Pragmatic engineer, one of the most respected software engineering newsletters with over 800,000 subscribers, published a deep dive interview with Boris Cherny, the creator and head of Claude Code at Anthropic. Cherny is a former principal engineer at Meta, where he spent 5 years, and the author of the O'Reilly book Programming TypeScript. He joined Anthropic in September 2024 and almost immediately started prototyping what would become Claude Code. The origin story is surprisingly scrappy. Cherny built a command line tool that used Claude to do something trivial, display what music an engineer was listening to. But the tool had filesystem access, and once other engineers at Anthropic got their hands on it, usage exploded. Cherny released a dog-fooding-ready version internally in November 2024. On day 1, 20% of Anthropic's engineering team adopted it. By day 5, that number was 50%. At that point, Cherny knew it had external potential. The interview digs into the actual architecture. Cherny doesn't run one Claude Code instance at a time. He runs 5 separate terminal tabs, each pointed at a different checkout of the same codebase, each with its own Claude agent working on a different task simultaneously. He starts every agent in plan mode. The agent proposes what it's going to do before writing any code. Cherny reviews the plan, pushes back where needed, then lets the agent execute. Once a plan is solid, the agent typically completes the implementation in a single shot. The workflow also relies on deterministic review patterns. These aren't vague code reviews. They're structured, repeatable checkpoints that catch regressions before they compound. Cherny describes a PR structure where each agent's output is scoped tightly enough to be reviewable by a human in minutes, not hours. One of the most striking data points, since November 2025, 100% of Cherny's own code has been written by AI, 0 manual edits. He directs the agents, reviews the output, and ships, but his fingers don't write production code anymore. This interview matters because it's not speculation. It's the actual workflow of the person who built the tool. And the patterns Cherny describes are already reshaping how teams operate at Anthropic. He reports a 200% increase in engineering productivity per engineer at the company. But the bigger implication is the role shift. Cherny says everyone on the Claude Code team codes now. Product managers, designers, finance people, data scientists. The boundaries between engineering, product, and design have more than 50% overlap. When non-engineers can ship features through agentic tools, the question of what makes someone a software engineer gets genuinely hard to answer. Cherny's prediction is blunt. By the end of 2026, the title software engineer will start going away, replaced by something closer to builder. The job isn't disappearing, but the skill profile is changing from syntax fluency and implementation speed to architectural judgment, system design, and the ability to direct multiple agents effectively. The person who can run 5 agents in parallel, review their plans critically, and catch subtle errors in their output is the new high performer. The person whose primary value was typing code fast is in real trouble. This maps directly to what developers are already experiencing. The value is moving upstream from execution to direction. The number to watch is that GitHub stat, 4% of public commits today, projected 20% by December. If that trajectory holds, it means Claude Code isn't just an Anthropic internal tool, it's becoming infrastructure for the broader software industry. Keep an eye on whether competing tools from OpenAI, Google, and others adopt similar parallel agent architectures, or if Anthropic's head start in this design pattern gives them a durable advantage. So Claude Code is reshaping how professional developers write software every day. But the most compelling proof that agentic coding tools have crossed a threshold didn't come from a Silicon Valley engineer. It came from a mathematician, arguably the greatest living mathematician, who used Claude Code for something far more demanding than shipping a web app. On March 7th, Terence Tao published a video titled "Formalizing a Proof in Lean Using Claude Code." The video racked up over 128,000 views on social media within days. For anyone outside mathematics, let me give you the context on why this matters so much. Terence Tao is a Fields medalist, that's the Nobel Prize equivalent for mathematics, and is widely considered the most talented mathematician alive. He's a professor at UCLA, has published over 350 research papers, and works across an absurdly wide range of mathematical fields, from number theory to partial differential equations to combinatorics. When Tao endorses a tool, the entire scientific community pays attention. Lean is a proof assistant, a programming language designed specifically for formal mathematical verification. When you write a proof in Lean, the software checks every single logical step mechanically. If there's a gap in your reasoning, Lean rejects it. No exceptions, no hand-waving. It's the gold standard for mathematical rigor, and writing Lean code is notoriously tedious and time-consuming, even for experts. What Tao demonstrated in the video is that he used Claude Code alongside OpenAI's O4 model to handle the grunt work of translating a mathematical proof into Lean's formal syntax. This isn't the AI doing the creative mathematical thinking. It's the AI handling the mechanical translation from human-readable proof to machine-verifiable code, a process that traditionally takes days or weeks of painstaking manual work. This fits into a broader pattern for Tao. Earlier this year, he used AI tools to formalize counterexample proofs for 3 long-standing Orosz problems, open problems that had resisted solution for decades. The Lean code for one of those proofs ran to 1,125 lines. Tao estimated that the AI saved him more than half the time and energy he would have spent writing that formalization by hand. The pipeline Tao and collaborators have developed is systematic. An AI generates or assists with the informal proof. A formalization system translates it into Lean. Lean's type checker verifies every step mechanically, and then a human expert, Tao himself, reviews and accepts the result. The prevailing narrative around AI coding tools has been that they're good for boilerplate CRD apps, web frontends, standard backend services. Useful but shallow. Tao's work demolishes that framing entirely. Formal mathematical verification is one of the hardest, most precision-demanding tasks humans do with computers. A single logical error in a Lean proof means the entire thing fails to compile. There's no close enough. And Claude Code is demonstrably useful for this work, not as a replacement for mathematical insight, but as a collaborator that handles the mechanical translation layer. This has implications well beyond mathematics. Formal verification techniques are used in hardware design, cryptographic protocol validation, aerospace software certification, and safety-critical systems engineering. If AI coding tools can handle the rigor required for mathematical proof formalization, they can handle formal verification in any of these domains. The pattern Tao demonstrates: human provides the creative insight and architectural judgment. AI handles the tedious mechanical implementation, is exactly the same pattern Boris Cherny described for software engineering. The tool is different, the domain is different, but the workflow is converging on the same shape. Humans direct, AI executes, formal systems verify. Watch for Tao's publication pipeline. A manifold prediction market is already tracking whether he'll publish a paper with Lean source code in it this year, and the trajectory suggests he will. If formal AI-assisted proofs start appearing regularly in top mathematics journals with Lean verification attached, it could establish a new standard where published proofs are expected to be machine-verified. That would be a fundamental shift in how mathematics is practiced and peer-reviewed. The developer who built one of the most used coding tools on the planet doesn't write code anymore. The greatest living mathematician uses AI to formalize his proofs. The question worth sitting with is, what does your role look like 12 months from now if these trends continue at this pace? If you want to stay on top of developments like these, subscribe. We cover AI and tech news daily. See you in the next one.